Welcome to the Unit 4 Day 5 notes. Go ahead and start by pausing the video and solving this system by elimination. When you're done, unpause and see how you did. All right, so personally, I'm going to choose to eliminate the x variable, so I need to multiply that bottom equation by -2. So the top one didn't change at all, but the bottom one is now minus 4x minus 14y equals -8. Not -8, -16. Make sure you distribute all the way across. When I add these things up, I now have -17y is equal to -34. So y is equal to 2. Okay, now if y is equal to 2, I got to plug this thing back in. So I'm going to plug it in to that top one, because why not? So I've got 4x minus 3 times 2 equals -18. 4x minus 6 equals -18. Add 6 to both sides. Divide by 4 to get x equals -3. So my answer should be -3, 2. If I plug that into either of these original equations, they should work out. So that's -12 minus 6 is -18. -6 plus 14 equals 8. We're good to go. All right, so today is just going to be solve things, solve systems of equations. We've done a few different methods, so we're going to try a few of them. So you need to be able to figure out which one you think is going to be the easiest for you in certain situations. So for me, for this one, if I don't have something solved for y and I've got a positive and a negative already, I generally like to just do the elimination method. I think that's easy for me, but I also have to be aware of some of these bigger numbers, because the bigger numbers might make it a little bit more challenging if I'm not paying attention. But I'm going to choose to eliminate the y in this problem. So if I want to eliminate the y, I'm going to have to multiply both the top and the bottom equations by something. To get to my common multiple of 12, I need to multiply the top one by 3 and that bottom one by 4. So now I have 9x minus 12y equals -21, and 20x plus 12y is equal to, well, 20 times 4, well, 25 times 4 would be a better choice, would be 100, and then I have another 8, so I have 108. All right, so when I add these together, I have 29x equals, well, 108 minus 21 is going to be 87. So if I do 87 divided by 29, I'm going to get that x equals 3. And now I'm plugging it back into one of the original printed equations. I'm going to plug it into this one because there's no negatives. So 5 times 3 plus 3y equals 27. I might have bigger numbers, but I get to avoid negative signs, which usually makes our life a little bit easier. So when I subtract 15 from both sides, I can see that y is going to equal 4, so my answer is 3, 4. Again, I should be able to plug this into both equations. 9 minus 16 is -7, perfect. 15 plus 12 is 27, also perfect. Now you could eliminate all the time, but we also need to be aware of what's happening, because it's very easy to say, oh, just multiply by 2 and go. But these things don't line up. My x's and my y's are stacked, not the x on x and y on y. So I'm actually going to solve this top one. I'm going to have 2y equals 6x plus 2. I just added 6x to both sides. Divide everything by 2. And now I'm going to take this value and plug it in there. So I've got 4x plus 3 times 3x plus 1 equals -10. So 4x plus 9x plus 3 equals -10. Subtract 3 from both sides. 13x equals -13, which means x has to equal -1. Now you can plug this into any equation. I'm going to plug it into that top one. So 2y minus 6 times -1 is equal to 2. Subtract 6 from both sides. Y is going to equal -2. So I have -1, -2. Now if I had just plugged this into here, I would have been able to get that as well. But I always want to plug it into the original thing, because if I messed up here and then plugged it into a wrong thing, that's not going to tell me if I made a mistake. So I want to plug into the original printed thing. So I've got -4 plus 6 is 2. Perfect. -4 minus 6 is -10. Also perfect. So for this one, if we're wanting to solve, I even if my x's and y's were stacked up, I have 2 variables on one side and then 1 on each side in the other one. So elimination might not be the best method here. Maybe it is. Kind of depends on your comfortability with solving. I'm going to actually choose the elimination method here just because of how weird some of these numbers are. Like a 31 throws me off, but I see that my y values are multiples of each other and my x values are multiples of each other. So I'm going to rewrite this. I'm going to get all of my x's on the left, all of my y's on the left. So my top one didn't change at all. But that bottom one, I'm going to have minus 9x plus 4y equals 31. Okay, I subtract the 9x from both sides. And now I see, okay, I've got them stacked up. Which one do I want to eliminate? Well, if I can avoid multiplying more tricky numbers, I like to do that. I'm going to multiply this bottom one by 2. If I do that, I have 3x minus 8y equals -17 on top still. Now I have -18x plus 8y equals 62. So when I stack these and add, I have -15x is equal to whatever 62 minus 17 is, which is 45. This ends up being kind of nice numbers, actually. Divide both sides by -15. X equals -3. Plug it into one of the original ones. I'm going to plug it in to the second equation because y is almost solved for it already. So 4y is equal to 9 times -3 plus 31. Well, -7 plus -27 plus 31 is going to be 4. So I've got that y equals 1. So I've got this ordered pair. Again, I should go check. -9 minus 8 is -17. Perfect. 4 should equal -27 plus 31, which it does. So we are good to go. Now it says use any method. If it tells you use any method, you can use whatever you want. If it tells you use any method and it doesn't give you a graph paper, definitely don't graph. Generally speaking, I'm not going to graph these because I've shown problems in the past where the scale is a little bit weird, or just by drawing it we're off by a little bit. It's kind of hard to see. So if I'm given something with slope-intercept form already, I'm going to just substitute it in. So I have -3x minus 4 times 2x plus 8 equals 1. If you are more comfortable with graphing, absolutely go nuts, graph it. That's totally fine. But I'm just going to do all of my algebra. And it's going to make my life a little bit easier, I think. So I've got -11x equals 33. So x equals -3. So now I'm just going to plug that into that original y equals stuff. So y equals 2. So I've got -3, 2. That is an ordered pair. That probably would have been very nice if I graphed this, but I'm not always guaranteed super nice solutions. But I should still check. Okay, if you graph it, that could be your check. If you just plug it back in, that can be your check. So I've got -3 times -3 is +9, minus 8 is 1. Perfect. 2 times -3 is -6, plus 8 is 2. Also perfect. Notice I checked this top equation first instead of this bottom equation, because this bottom equation is how I got that y equals 2. So of course it's going to work from there. So again, you can use whatever method you want to. It's tempting to want to use elimination at this point just because things are stacked, but they're not actually stacked because of where the equal signs are. So you would have to worry about that before you start multiplying top and bottom equations. What I'm going to do instead is I'm going to take this bottom equation, I'm going to solve it for x. I like fractions, so I want to work with some fractions this time. So I'm just going to plug this in. So I've got 3 times 3y over 2 plus 5 over 2 equals 7. Maybe I get to this point and I go, maybe I don't want to do that. That's fine. You can always pick a different method. But now I've got 9y over 2 plus 15 over 2 equals 7. I'm going to rewrite 7 as 14 over 2. Okay, it's just a common denominator. I see everything's over 2, so I'm just going to get to that. Now when I subtract 15 over 2 from both sides, I've got 9 halves y is equal to negative 1 half. Multiply both sides by 2. 9y is negative 1. So y equals negative 1/9. All right, well, I got to plug that number in somewhere. I'm definitely going to plug it into this bottom equation because I know 1/9 and that 3 are going to kind of help each other out a little bit. So 2x is equal to 3 times negative 1/9 plus 5. 3 times negative 1/9 is negative 1/3. 5, if I write it as thirds, is going to be 15 thirds. So 2x is equal to, well, 14 thirds. Divide by 2. If I'm dividing by 2, it's like multiplying by 1/2. So 14 divided by 2 is 7 on top over 3 on bottom. So my ordered pair would be 7 thirds, negative 1/9. That seems terrible, so I should really double check my answer. Okay, in my calculator, it might even be better to do it there. 3 times 7 thirds is 7. All right, so that tells me I'm probably going to make a mistake because negative 4 times negative 1/9 is not 0. So that tells me I messed up somewhere and I should go back and fix it. It's probably because I did this fraction business to start with, and then I didn't make, I made some mistake along the way. So I don't really know where my mistake is, so I can go back and search for it. So like here, maybe I made a mistake at that point. Well, 14 over 6, divide top and bottom by 2. Okay, that's 7 over 3. Yeah, that's what that's supposed to be. 15 divided by 3 is 5. Yep, so that's good. So I don't know what my mistake is. Maybe at this point I just say, you know what? I've made a bad choice to start with. I'm going to start over. Because I already figured out, hey, my answer is wrong. I'm not going to leave it that way. I'm not going to throw in the towel. Instead, I'm just going to start over. Sometimes you can start from scratch. Sometimes you don't start from scratch. Perfectly okay. I chose that method, so I'm going to choose a different method this time. Maybe this time, because I saw that they weren't the same, maybe there's an issue that pops up if I graph it. So maybe I want to graph this one. So that top equation, if I want to graph this, I'm going to move that 3x over, so I have negative 4y is equal to negative 3x plus 7. Divide everything by negative 4. I've got y is equal to positive 3x over 4 minus 7 over 4. All right, so that's a weird fraction. I don't really like that, but let's change that other one to slope-intercept form also. So that'd be 3y is equal to 2x minus 5. Okay, I kind of did a little hocus-pocus there. I just flopped the sides, so 3y plus 5 equals 2x, and then subtract 5 from both sides. So y equals 2x over 3 minus 5 thirds. Yeah, I definitely don't want to try to graph those things, because if I try to graph those things, I have b values of different types of fractions, but those y values are the same. So maybe I should just set them equal. So 2x over 3 minus 5 thirds is equal to 3x over 4 minus 7 fourths. All right, well, I should find a common denominator of everything. So I'm just going to do it all at once. I need to get everything over 12. So that's going to be 8x over 12 minus 20 over 12 equals 9x over 12 minus 21 over 12. I just multiplied everything on the left side by 4 over 4, on the right side by 3 over 3. I'm going to subtract 8x over 12 from both sides. All right, and then I'm going to also add 21 over 12 to both sides. If I do that, I end up with 1/12 equals x over 12. Well, multiply both sides by 12. Get x equals 1. That seems like a way nicer number than what I had the first time. So I must have made some real big mistake before. Or maybe I made some real mistake now. We'll find out when I plug this thing in to figure out what y equals. So if I plug this into the top one, we'll go top one. 3x, well, 3 times 1 minus 4y is equal to 7. Minus 3 from both sides. Negative 4y is equal to 4. Y is equal to negative 1. That seems way nicer. Now I've got the answer of 1, negative 1. All right, well, I should double check to see if that works, because I'd already made a mistake once, so I should double check. So 3 times 1 minus 4 times negative 1, that's 3 plus 4 is 7. Perfect. 2 times 1 is 2. 3 times negative 1 is negative 3 plus 5 is 2. Yeah, that works. All right. That's my answer. So I don't know what my mistake was the first time, but it's okay. We've got to know when to say, okay, I made a mistake, I should find it, and when to say, I made a mistake, I'm not going to worry about it. I'm just going to go back and redo the problem a different way and find it. Okay? And you don't necessarily need to know exactly where your mistake was, just that you made a mistake. All right, so for this next one, x has already been solved for in that top equation, so I'm going to say 3 times 4y minus 3 minus 6y is equal to 3. I'm going to substitute 100% of the time if I have something like this where one of the variables excuse me, is already solved for, I'm going to substitute every single time. So I've got 12y, helps to write if you actually have a pen instead of a highlighter, minus 9 minus 6y equals 3. So we get that 6y is equal to 12, which means that y has to equal 2. If y equals 2, plug that in here. X is equal to 4 times 2 minus 3. X equals 5, so my answer is 5, 2. Now, I definitely made a mistake on the problem before, so I really got to make sure I did this one right. 4 times 2 is 8, minus 3 is 5. Perfect. 3 times 5 is 15. 6 times 2 is 12. 15 minus 12 is 3. All right, I know my answer is correct. Like I just said before, anytime I have a variable solved for, I'm going to substitute. Even if it was in slope-intercept form, to me it's just a lot easier to do the algebra. Now there are times, I suppose I shouldn't say 100% of the time, there are times where it's going to be easier to graph. That's going to be more so if I see two y equals mx plus b's right next to each other. Then that's not that bad. But generally speaking, graphing is going to take you longer and you're more likely to make a mistake. Add 20 to both sides. I've got 22x equals 22. So x equals 1. Plug that into the thing that is already solved for y. Y is equal to 5 times 1 minus 5. That's 0. All right, 2 times 1 is 2, plus 0 is 2. Perfect. And I just found 5 times 1 minus 5 is 0. Perfect. So here's the summary, a place for you to write things down that we talked about today. Any questions you may have, questions you might want to ask next time you come to class. Hope everybody has a great day.